Okay, this is the answer key for the review number 2 for your test. We have an interior sum of 2,880 degrees. We need to figure out how many triangles are contained within that shape, and then we need to add 2 back for those number of sides. All right, so that gives us 16 plus 2 is 18 sides. Okay, question number 2. The sum of each interior angle is 120. So when we see the interior angle, we want to think each exterior, and each exterior is supplementary to each interior. So that means each exterior is 60 degrees. So if we take the exterior sum of 360, divide that into 60-degree angles, we will have 6 sides. So we would have a hexagon if I asked you to name the polygon. Okay, number 3, the exterior sum of a tridecagon. Even if you're not sure what a tridecagon is, every polygon has an exterior sum of 360 degrees. Number 4, the 2 angles of a pentagon. And a pentagon has 5 sides, so that I know the sum of the interior, which is 3 triangles, would be 540 degrees. So in my pentagon, which says 540 degrees, I have a 130-degree angle and a 70-degree angle, and the rest are in a ratio of 4 to 5 to 8. So I need to make that a 4x, a 5x, and an 8x, because that ratio was reduced by some greatest common factor, which is x. That's what we're trying to find. So we have 540 degrees is equal to 200 degrees plus 17x. Subtracting 200 to the other side, we have 340 degrees is equal to 17x. And dividing by 17, we have x is 20. So we're not done there, because we have to find the missing angles, not just solve for x. So we need to take 4 times 20, which is 80 degrees, 5 times 20, which would be 100 degrees, and 8 times 20, which is 160 degrees. So the 80, 100, and 160 are my final answers. Okay, number 5, we're talking about a square. We have to think about all the properties of our square. We have 4 congruent sides. We have 4 right angles. We have diagonals that are perpendicular bisectors. We have diagonals that are congruent. And we also have diagonals that bisect the angles. So we need to think of 45, 45, 90. So our ratios are the side, and then the side times root 2 gives us our hypotenuse. So with all that in mind, we're given a perimeter of 24 inches. So that means that each side is 6 inches, because we took 24 and we divided it by 4. So if each of our sides are 6 inches, we could find our diagonal, which would be 6 root 2. We're also thinking about finding half our diagonal, which is AE. So you could either look at the smaller right triangle and say the hypotenuse is 6, and when we divide by root 2, we get 3 root 2 and 3 root 2. Again, I apologize, I'm using my airliner, which makes it a little challenging to write. Or we could have looked at the big triangle and said, wow, we have side, side, side root 2, and our sides are 6. Our whole diagonal, AC, is 6 root 2. And then we take our 6 root 2 and divide it by 2 to get AE, which is 3 root 2. So there are two different ways you could have went about finding your 3 root 2. Okay, number 6. So this 20-degree angle was hard to see for some reason when it was posted online. But we have a rectangle and we have a hypotenuse of 36 meters and we need to find the area. So in order to work with area, we need to have length and width. Okay, so what we're looking at is a right triangle with a 20-degree angle and a hypotenuse of 36. So we have H. I'm going to see if I can kind of redraw this. The airliner is getting tricky. Oh, that's terrible. Okay, we're going to give it one more shot. Thanks for being patient. Let's see if we can use our shape maker here. And we'll see if I can kind of clean this up a little bit. So we have a 20-degree angle. And if you need to, I'll flip it over and you can reorient it. Otherwise, you could apply all your properties. But we have a 20-degree angle. And we have a length of 36 meters. We're looking for the opposite. Oh, I'm sorry. We have a hypotenuse, which is across from the 90, of 36 meters. We have an opposite and an adjacent that we need to be able to solve for. So with that, we have an H, an A, and an O. So we're going to be using our sine of 20 degrees is the opposite over the hypotenuse. And we're also going to be solving the cosine of 20 degrees is the adjacent over the hypotenuse. In both these cases, the variable is high. And since the variable is high, we know that we need to be able to multiply. So we have, oh my goodness. I can get it together here. We have 36 sine of 20 is equal to x, and we have 36 cosine of 20 is equal to y. So making sure that you're in degree mode, we have an x of 12.3. And we have a y of 33.8. So our area is 12.3 times 33.8, which is 415.74. Okay, that's our final result for our area, and that's meters squared. Again, thanks for hanging in there with the technology. It's becoming a bit of a challenge, but we can work through it. Okay, number 7. We have an angle of 110 degrees. So my 110 is my big angle down here. And I also have a side length of 13 centimeters. So I have to look at this quadrilateral and say, okay, what figure could I have? So I have diagonals that are perpendicular, but those diagonals are not congruent to one another. So I should be able to conclude that I have a rhombus. And I know the area is equal to the diagonal times the diagonal divided by 2. So I have to think about all my properties, and one of my properties tells me that the angles are bisected by the diagonal. So with that being the case, I know that I have a 55-degree angle here. And that 55-degree angle shows up in a right triangle in which I have a hypotenuse, adjacent, and an opposite side. And I need to find the lengths of both my diagonals to be able to work in the formula. So I have to find one diagonal and I need to be able to find a second diagonal. And it doesn't matter which is which. So I'm going to set up and use my trig rules. So I'll call this X and I'll call that one Y. So I'm going to take the sine of 55 degrees is equal to the opposite over the hypotenuse. Again, the variable is high, so I know I have to multiply to find X. And then I'm going to use my cosine rule to find the adjacent. Again, the variable is high, so I know to multiply. And both of these in my calculator are going to yield a 10.6 and a 7.5. So I know half of each of my diagonals. So if X is 10.6, then I can now go back and say, well, one of my diagonals is double that. Okay, so that's a 21.2. And then my second diagonal is double 7.5, which is 15. So now in my formula for my area is equal to diagonal times diagonal divided by 2. So I get an area of 159 squared centimeters. And my perimeter, well, that's just adding all four sides together as if I was going to put a fence around it. So that would be 4 times 13, which gives me 52 centimeters. Okay, we need to find the area and the perimeter of this trapezoid. So in order to find the area, we need to do median times height. So we need to find the bases. In order to find all those, okay, I apologize. In order to work with the area, we need to have the median times the height, which means we need to find the bases. In order to have the perimeter, we need to find all four sides. So we can start with our short leg, which is 12 feet. We take our short leg and we multiply it by √3 to get our long leg. We take our short leg and we double it to get our hypotenuse. Now this 3 feet comes back down here to be 3 feet. And this 12 feet for an altitude is also a 12-foot altitude over here. So now our long leg is 12. So we need to divide our long leg by √3. And when we do that, we get a short leg of 4√3, which gives us a hypotenuse of 8√3. So we need to take our perimeter by adding all of these sides together. So if you want practice for exact, there you go. There's your rounded. In order to find the area, we need to do median times height. So our bases are 3 and 39.2. So that gives us a median of 21.1. So our area is 21.1 times 12, which is 253.2. Okay, please note there's a correction in this problem. KJN is 100 degrees. Alright, if KN is 18, and that's in a ratio of 1 to 2, then we need to split that into thirds, which gives us 6 and 12 because we have our parts equal to 6. With that, we need to be able to find our diagonals, which we have to find our area, diagonal times diagonal divided by 2, and then our perimeter. I apologize, I'm out of time.